3 is just converses to 3-2. What's a converse? The opposite. It's your if P then Q. The converse would be if Q then P, right? So it's going to look so identical to what you did in 3-2. The only difference is in 3-2 we said if the lines are parallel, then corresponding angles are congruent. If the lines are parallel, then alternate interiors are congruent. If the lines are parallel, then same side interiors are supplementary, right? Today, now we're going to say if alternate interiors are congruent, then the lines are parallel. If same side interiors are supplementary, then we know the lines are parallel. So on Tuesday, we said we know the lines are parallel. What can you tell me about the angles? Hey, gentlemen, can you put the iPad away or turn this way so you're not distracting each other with it? So it's just going to be looking at it in a different light, but they're going to look very similar. You're going to do a lot of the same things. You're still going to set things equal or set things supplementary. So I'm not even going to write out entire theorems for you. I'm going to shorthand each one just 1, 2, 3, 4, and then we'll try a few problems with it, okay? So it's the converse of corresponding angles. Okay, this says if corresponding angles are congruent, then the lines are parallel. Okay, so that's the converse of corresponding angles. There's got to be a better way to write this that you don't have to write every single one out separate, but I haven't figured it out yet. So the converse of alternate interior angles theorem says the same thing, but with AIA instead of corresponding angles, right? So if alternate interior angles are congruent, then the lines are parallel. Okay, and then the converse of alternate exterior angles says the same thing. Really, if you wanted to, you could just write 3 different times without having to write the title every time. That's up to you how you want to do that. But the converse of alternate exterior angles theorem says if alternate exterior angles are congruent, then the lines are parallel. Oops, not equal. God bless you. Okay, so those are the 3 that if the angles are congruent, then we know the lines are parallel. So I could give you a picture just to kind of represent all 3 of them here. Basically what it would say is if this is A, B, C, and D, and I have angle 1, angle 2, angle 3, angle 4, 5, 6, and 7, and 8. So let's say this is our picture. If they tell us right now that angle 1 is congruent to angle 4, what kind of angles are those? Those are corresponding, okay? So the converse of corresponding says if corresponding angles are congruent, then what? The lines are parallel. So which lines are parallel right now? A and B, right? Because angle 1 is here, angle 4 is here. So your parallel lines would be these 2. Your transversal, this one, okay? So I would say if angle 1 is congruent to angle 4, which it is, then we know that A is parallel to B. So whenever this is your statement, you're using a converse. Then the lines are parallel, it's a converse, okay? You will have to distinguish on your quiz between the original and the converse. So the original will say angles are congruent, or Angles are supplementary, already knowing that lines are parallel. The converse will say, if the angles are congruent, then the lines are parallel. Are we clear on that? Okay. So there's that one. I'm going to take some of these red lines away. Oh, I can't. Just kidding. Maybe I can. Let me see. Nope, we're not going to do that. Shoot. It won't let me undo anymore. Bummer. Sorry. We're going to draw that back in. Okay. So if I told you right now that angle 6 is congruent to angle 7, which lines are parallel? If I'm using 6 and 7. Which ones? A and B again, right? Okay, so this first one, 1 congruent to 4, that was the converse of corresponding angles. This one, we would say if angle 6 is congruent to angle 7, that's a 6 again, 7, then we know A is parallel to B. Which converse is that? What kind of angles are 6 and 7? Alternate interior angles. So that's the converse of alternate interior angles. Okay. What if, this is super messy, sorry. Can you tell that's a 3? It's horrible. What if I said if the measure of angle 2 plus the measure of angle 3 is 180, then what is true? So if 2 plus 3, oh no, I'm going to change that. I'm going to make this 6. If the measure of angle 6 plus the measure of angle 3 is 180, then what is true? Which lines are parallel? If I'm using 3 and 6. That would be C and D, right? Here's angle 3. Here's angle 6. The only line that I haven't touched right now is line A, right? So the 2 lines that have to be parallel are the 2 that are being touched that could be parallel. So that would be C and D. So we would say then C is parallel to D by the converse of what? What kind of angles are those? Same side interior angles. Okay. Which I haven't even given you yet. We'll write that one down right now. So the converse of same side interior angles just says if 2 angles are supplementary, two same side interior angles, we'll say, are supplementary, then the lines are parallel. Okay, so those are the 4 theorems. Basically, you're looking for what types of angles are we talking about, and is it the original, where I know the angles are congruent or supplementary, or is it the converse, where I then know that lines are parallel? Okay. All right, we are going to do a proof. So let's say we're given that angle 1 is congruent to angle 7. And we need to prove that L is parallel to M. Okay? And I'll tell you this, whenever you're proving lines parallel, your last step of your proof is going to be the converse of something, right? Because if we have to prove lines are parallel, we have to use a converse. So keep that in mind when you're doing proofs. If it's saying prove lines are parallel, you're going to use a converse somewhere. So here's L, here's M, and this is angle 1, angle 3, angle 5, angle 6, and angle 7. Okay, so we're trying to prove the lines parallel. We know that 1 is congruent to 7. So if it helps you to see it, go ahead and just mark that. Mark what you know in your proof. So we know 1 congruent to 7. Where do we start with our proof? The given, right? Which was 1 is congruent to 7. So we're going to say angle 1 is congruent to angle 7 because it's given. Do I need to slow down a little bit? Okay. That's all the quick stuff, so we'll slow down until everyone's there, and then we'll do the next step. Okay, so we know that 1 is congruent to 7. We're trying to prove the lines are parallel. We're not going to use the converse of alternate exterior right now. We're going to pretend we don't know that one yet because this is actually a proof of a different theorem. So we're trying to prove the converse of a different one, but I don't want to tell you which one yet because I want you to get there. But just know we're not doing alternate exterior right now, okay? Because I know right now you'd be like, well, duh, those are alternate exteriors. So yeah, we know the lines are parallel. I get that. We're going to pretend we don't know that, okay? What can you tell me about any angles in this picture that would help us to prove lines parallel? Can you tell me anything about angle 3? How about?
It's vertical to angle 1, which makes it corresponding to angle 7, which makes angle 3 and angle 7 equal.
And that's your proof right there. Okay, so step 2 is we know that angle 1 is congruent to angle 3. Why are 1 and 3 congruent? What kind of angles are those? Not corresponding. Those are vertical angles. You're going to use vertical angles a lot in proofs, just so you know. So look for them because they show up quite a bit. Okay, so we can say 1 is congruent to 3. So if I know that 1 was congruent to 7 and 1 is congruent to 3, then I can take out the 1s and say that angle 3 is congruent to angle 7. How do I know that? Why is 3 congruent to 7? Substitution or the transitive property. Why can't I say corresponding angles right now? What does the corresponding angles theorem say? If what?
Parallel.
If lines are parallel. And we don't know that lines are parallel, right? We're trying to prove that lines are parallel. So a lot of times people want to say right here, oh, corresponding angles. But you cannot use the corresponding angles theorem unless you know that lines are parallel. So you can't do corresponding here. So instead, we're going to say transitive or substitution. Either one of those would be fine. Okay, so now that I know 3 is congruent to 7, now I can say that L is parallel to M by which theorem? We said those are corresponding angles. What do you have to use when you prove lines parallel? The converse. So you would say converse of corresponding angles. Okay, and that would be the whole proof. So, yes, you could have done alternate exteriors at the beginning, but we're pretending for a second we didn't know that yet. This would be a proof of the converse of corresponding angles. Okay, 2 more. This one's quick. So let's say we have this, And here's angle 1, here's angle 3, and here's angle 2. And it says angle 1 is congruent to angle 2. The question is, are the lines parallel? Okay, can we prove the lines are parallel? So we're not going to write out a full proof right now, although that's essentially what you're thinking through is, can you prove the lines are parallel? So if I know 1 is congruent to 2, are those lines parallel? Who thinks yes, those are parallel lines right now? Who thinks no, those are not parallel lines? So I got a couple yeses. The yeses are correct. Why are they parallel? Alternate exterior angles are congruent. If alternate exterior angles are congruent, then the lines are parallel. So we would say yes. By the converse of alternate exterior angles, right? If alternate exteriors are congruent, then these would be parallel, okay? All right, last thing. And this one's gonna look just like what you did Tuesday. They're gonna word it differently, but you're gonna solve it exactly the same way. So you have line A and line B, a transversal here, and this is 2x plus 9, and this is 111, okay? The question is, and this is the way they'll word it, but you're solving it the same. They'll say, what is the value of x that would make A parallel to B? Whereas on Tuesday, it said, A is parallel to B, solve for x, right? Now we're saying, what would x have to be in order for A and B to be parallel? You do the same process. So how would I set this up in order for A to be parallel to B? What kind of angles are those? Those are same side interiors, okay? What do we know about same side interiors? They are supplementary. So you're just gonna take this and say 2x plus 9 plus 111 and set that equal to 180. So 2x plus 120 equals 180. You're gonna take away the 120, so 2x equals 60. And then divide by 2, so x is 30. Okay, so yes, it's going to be worded differently, but don't let that throw you off. You're still going to set same side interiors, supplementary, and you're going to still set alternate interiors, alternate exteriors, and correspondings equal to each other. Okay?